Right, guys, this is our last lesson this term, okay? And we're gonna learn about something called the scale factor. It's really not difficult, okay? I'm gonna use this problem. So, by the way, page 250. So we've got a cylinder. The height is 6 centimeters. The diameter is 8 centimeters. And to begin with, let's just calculate the surface area. So the surface area, okay, these are equations that you need to, it's not completely irrelevant, but you really need to know. Okay? So the surface area is made out of two circles, top and bottom. Okay? So it will be 2 pi r squared plus the surface area which wraps the cylinder. So if I'll just have a look at this cylinder here, okay, we've got the surface area around that one. Okay, and hopefully in grade 9, somebody told you, a teacher told you, how are we going to calculate the surface area of this thing around? Well, this thing around, if you think about it, is a rectangle, isn't it? If you can slit it open and you wrap it around, you'll get a rectangle. The height, or the width of this rectangle is the height of the cylinder, 6 centimeters. The length of this rectangle is basically the circumference of the circle, 2 pi r. Okay, so the area of this rectangle is h times or 2 pi r h. Okay, 2 pi r times h. Okay, that's the area of the rectangle. Okay, and in this case, let's put in some numbers. So 2 times pi times r. What is the radius? The radius, if the diameter is 8. The radius is obviously 4. Okay, so 4 squared plus 2 pi times 4, h is 6. Okay, so we'll put that in the calculator in a minute. Okay, but let's calculate the volume first. Okay, so how we calculate volume, and this I did tell you guys not on the video, I told you that yesterday, so maybe I'll repeat it. When we're calculating areas, volume, surface areas of volume of shapes, most of the shapes we've come so far are what we call prisms. Okay, what is a prism? Okay, we looked at a cuboid, which is like a box. We looked at triangular prisms, which would look like this. Okay. Something like that. And now we've got cylinders. They are all prisms. What's in common for all these prisms? They've got a top and bottom which are identical. Okay, so our cylinder here have the top and the bottom, and they're identical. Okay, this year we're going to move on to things that don't have a top and a bottom, like a pyramid. Okay, but a way of calculating the volume of all prisms is always find the area of base. Okay, in this case it's this circle. In a triangular prism it will be the area of the triangle. So find the area of the base and then time it by distance between bases. Okay? In this case, we call it height, but it's basically the distance between the two bases, this distance. Okay? So in this case, the area of the base is going to be pi r squared, and the distance between the bases will be h. And now I'll put them these numbers. Okay, it's going to be pi times 4 squared times h, which is 6. Okay, so I'll just pause here, find the answers, and we'll move on from here. So I've used the calculator, and I found the surface area to be 80 pi and the volume 64 pi. Now, in a test, you should really press the S and D button, then you get a decimal place. But actually, I don't want to do it now. You'll see in a second why. Okay? So really, this is not a reason why I've done this question. This is grade 9 stuff. I've done that. Okay? What we're learning now is this thing about scale factors. So in this question, which I took from exercise 2, they tell you, right, we're doubling all the measurements. So basically doubling the diameter. So the new diameter now from 8, we're going to 16. Okay? The diameter. And the height is going to go from 6 to 12. And the question I'm asking, all right, I double the measurements, what will happen to the surface area and the volume? And I'll pause here, and I want to see what you guys think. Okay, so I've heard different thoughts. Some people think, okay, we doubled the lengths, so everything will double. And Ollie thinks something maybe quadruple times 4, but I'm not sure which one. Okay, so let's just first of all try and do it, and then we'll try and explain. So, what I'm going to do, I'm going to rewrite these answers. So this is now the new surface area. I'll write in red. Okay, yeah, I'll write in red, and I'll keep this one. So the new surface area and the new volume will be as following. Okay? So 2 pi r. 2 pi. What is the r right now? Okay, if the diameter went from 8 to 16, what will be the r? 8. Okay, the new r will be 8. It went from 4, it will double to 8. So 8 squared. Okay? Plus 2 pi r, which you guys told me already is 8. And what is the diameter, the new height now? From 6 we went to 12 times 12. Okay? So from 4 to 8, from 6 to 12. Okay. And we're going to add that all up. Okay? Maybe now I'll use calculators. Okay? So 8 squared is 64 plus, not plus, times 2 plus 16 times 12 plus 16 times 12. I'm getting 320. Okay. 320 pi. Okay? We'll check, we'll compare in a minute. Ollie is already figuring out something. Okay? Let's do the volume. Okay? The volume is pi r squared. R you told me is already is 8. So 8 squared times 12. The height is 12. So I'm going to calculate 8 squared is 64. Then we need to calculate times 12. The answer I'm getting is 768. Okay. Now let's compare all these numbers. Let's start with the surface area. From 80 pi to 320 pi. Use another thing. What are we doing? How much did I multiply 80 to get to 320? Time? 4. Time 4. So Ollie was absolutely right when it comes to surface area. Okay? If I multiply the dimension by 2, then the surface area is multiplied by 4. Now why is that happening? Look, from 4, I went to 8. So I doubled it. But I doubled the dimension, but it's squared. So the square of 4 or square of 8 is 4 times the square of 4. So because of that square, okay, that's the timing by 2 actually eventually happens to become time 4. Okay, I'll try and give you a simpler way of explaining it. Okay, so if I take a paper and then this is a paper. Let's say I have it's 2 by 3. So the area of 2 by 3 will be 6, right? If I doubled all the dimension, okay, so from 2, it's going to become 4. From 3, it's going to become 6. Okay? So I've got 6 and 4. Now the new dimension will be 4 times 6. It will be 24. You can see that the area didn't double. It's quadrupled, isn't it? You can even see it in your eyes. So doubling the dimension quadruple the areas. Okay? Now we'll take that into later. Let's look now at the volume. Okay? We went from 64 pi to 768 pi. How much time did we do it? Use your calculator. How much is 64 to 768? So do basic 768 divided by 64. Is it 12? Yeah, okay, so I need to do 2 times 2 times 2. Let me just pause here for a second. I want to make sure of that. Right, so I made a little mistake. We realized I made a mistake. That was 64, but that's wrong. Because 4 squared times 6, 16 times 6 is definitely not 64. It should be 96. And from 96 to 768, okay, we actually timing by 8. Okay? So whilst the area, the surface area, we time by 4, the volume we time by 8. Why is that happening? Because check out, look to this. Okay? Here, if I compare this term to this term, okay, 4 to 8. 6 to 12. We double the dimension, but we've got that square. So that square means that 4, so 8 square is 4 times 4 square. But now we still have 12, which is double in 16. So we are timing it by 8. Okay? If I go back to this picture, well, it will be difficult for me to draw 3 dimension. But imagine that this shape also had a third dimension. Then I calculate the volume. For every dimension I double, okay, in every area, in every length, in every direction, then I'm timing the volume by 8. Okay? So let's wrap it out and do a more general case, and then that will be it. Right, so to summarize and to generalize it, let's say we have a shape with, I took for example a box, but it could be any other shape, 3-dimensional shape, but the lengths are A, B, and C. Now let's say I multiplied, I increased all the dimension, I multiplied them by K. That's what we call a scale factor. So our K in the example we used was 2. We doubled all the dimension. But obviously I can time it by 1.5 or by 7.8. So if I'm timing all the dimensions by K, the surface area, the new surface area, will be timed by K squared. In our example, K was 2, so we timed the surface area by 4. The volume will be timed by K cubed. In our example, K was equal to 2, so we timed the volume by 8. Does that make sense? Okay, now an example we didn't talk about, but it's going to be quite obvious. Okay, if let's say sometime I didn't say that K must be larger than 1. We can actually shrink. We can go from a big object to a small object. So in fact, K can, for example, be equal to 0.5. Let's say we half all the dimension. What will happen to the surface area in this case? Okay, if K is equal to 0.5, divide by 2. What do we time? We time it by, it tells you here, this is the formula, this is what you got to remember. Okay? We time the dimension by K, the surface area will be timed by K squared. So what do we have? Yeah, time by 0.5 squared. Okay? The surface area, the new surface area, will have to be timed by 0.5 squared, which is really a quarter, isn't it? 0.25. Then divide by 4. Exactly. So if you halve all the dimension, this new surface area will be divided by 4. The new volume, okay, and the new volume will be timed by 0.5 power 3, which is 1 over 8. So in other words, we divide it by 8. Alright guys? Okay, so what I will ask you to do, and we're not going to have to do it today, but have a look at it please, early in the holiday I suggest, because otherwise you want to have a holiday. Just go a few example questions and exercise 2 on page 250. Not too many, it's not too difficult. Just do 2, 3 is enough. Okay? Cool.